On the morning of September 26, 1955, an ironworker climbing the south tower of the Mackinac Bridge reached 300 feet above the Straits of Mackinac and looked north. The tower wasn't finished. Steel rose to about half its eventual height, and above that, nothing but open sky and wind coming straight off Lake Michigan with nothing in between to slow it down. He was standing on a steel beam 12 inches wide, with 250 feet of open air below him, then 200 feet of cold, fresh water before the bottom. The tower would eventually reach 552 feet. He'd go up with it. This is the story of how Michigan built the longest suspension bridge in the world across 5 miles of the most dangerous freshwater strait in North America, a project the state had been told for 70 years wasn't possible, then wasn't affordable, then wasn't politically survivable, and got built anyway. 3,500 men spent 3.5 years in water, wind, and sub-zero temperatures building something that will outlast every one of them. 5 of them didn't leave the site alive. Michigan is really 2 places split by 5 miles of water. The lower peninsula holds Detroit, the auto plants, most of the population. The upper peninsula is forested, sparsely populated, and connected to the rest of the state only across the Straits of Mackinac. But it held the copper that supplied 1/3 of America's output for decades, the iron ore feeding the steel mills downstate, and timber that had fed the logging industry since before the Civil War. Everything moved south across those straits, either by boat or by waiting for winter ice thick enough to drive across, a practice that regularly killed people who misjudged how solid that ice actually was. By summer, crossing meant a ferry, and by the early 1950s, that ferry system had completely broken down under the weight of Michigan's booming car culture. A driver arriving on a Friday afternoon in August of 1953 might wait 16 hours in a line stretching back for miles, watching people run out of gas and children get sick in the heat, with no priority given for medical emergencies or funerals. The Straits didn't care about anyone's reasons. Everyone agreed a bridge was the answer, and everyone had agreed on that since 1884. When the first formal proposal went to the state legislature and simply died there. It died again in 1920. It died again in 1934, when no construction firm would even bid because the financing didn't exist. It died in 1940, in 1944, and again in 1947, when state engineers put the cost at $17 million against traffic revenue that wouldn't come close to covering it. Every study said the same thing. The water was too deep, the currents too strong, the ice too severe, the cost too high. What finally changed wasn't the engineering. It was the politics. Governor G. Menon Williams, elected in 1950, pushed through a financing structure that didn't touch the state's general fund at all. The Mackinac Bridge Authority would issue revenue bonds backed entirely by future tolls, meaning bondholders carried the financial risk, not taxpayers. But selling those bonds required something no politician could provide: a genuinely credible engineering plan. The authority hired David Steinman in 1953, 63 years old. Raised poor in the shadow of the Brooklyn Bridge, the son of immigrants who'd spent his childhood deciding that bridges were what he wanted to build. He'd already designed major spans across 5 continents. But what actually made him right for Mackinac was his understanding of why the Tacoma Narrows Bridge had torn itself apart in a 42-mile-an-hour wind back in 1940, and the most consequential failure in suspension bridge history. That deck had been built thin and light to save money, and it had begun oscillating in the wind at a frequency matching its own natural resonance, twisting in growing waves until the whole structure exceeded its own strength and fell into Puget Sound. Aerodynamic flutter. Steinman had actually been warning about exactly this risk since the 1930s. Nobody had listened until Tacoma Narrows collapsed on camera. His Mackinac design confronted the problem head-on. A wide, heavy, stiffened truss deck with the outer roadway lanes built as open steel grid instead of solid pavement, so wind could pass straight through instead of building up pressure underneath. The total span between anchorages ran 8,614 feet, the longest suspension bridge in the world at the time it opened, with towers rising 552 feet above the water. Steinman tested wind tunnel models and calculated the structure's natural frequencies to guarantee they sat safely outside anything the Straits could throw at it. Construction began May 7, 1954. The workforce came from entirely different worlds. The iron workers came from Kanawake, a Mohawk community on the St. Lawrence River, part of a tradition dating back to 1886, When Mohawk laborers working a railroad bridge near Montreal reportedly walked out onto newly exposed high steel with no apparent fear at all, and the construction superintendent immediately hired every one of them for the most dangerous work available. That reputation carried across generations. Built on something entirely real, the specific combination of balance, spatial awareness, and the ability to function at full mental capacity while the wind moved and the steel swung far above solid ground. Alongside them came commercial divers experienced in compressed air work, and Michigan laborers from the mines and logging camps of the Upper Peninsula. If a story like this is worth your time, subscribing helps make sure more of them find their way to you. The foundation work was what made Mackinac genuinely unprecedented in American bridge engineering. The main tower foundations had to sit at the bottom of 200 feet of freshwater, depths no American bridge project had previously attempted using deep-water caisson construction. A caisson is a massive hollow steel tube, sealed at the top and pressurized with compressed air to keep water out of the working chamber at the bottom, where men descended through an airlock to excavate material as the whole tube slowly sank toward bearing rock. At 200 feet down, the air pressure required ran roughly 90 pounds per square inch above normal atmosphere, enough to saturate a worker's blood and tissue with dissolved nitrogen over a 4-hour shift. Surface too quickly, and that nitrogen comes out of solution the way carbonation escapes a shaken bottle, forming bubbles in joints, causing the crippling pain that gave decompression sickness its name. The bends, or worse, bubbles in the spinal cord causing paralysis, in cerebral vessels causing strokes, in coronary vessels causing cardiac arrest. By 1954, U.S. Navy decompression tables specified exactly how slowly a diver needed to ascend at any given depth. But a man who spent 4 hours doing hard labor in cold, pressurized air and just wants to get warm is a man whose judgment about his own ascent speed is not entirely reliable. And in a schedule-driven construction environment, compliance wasn't always perfectly monitored. Those caissons are still down there today, holding the weight of every vehicle that's crossed since 1957. Winter conditions on the surface were their own separate danger. Temperatures regularly dropped below 0 Fahrenheit, with sustained winds off Lake Michigan exceeding 30 miles an hour. Cold enough that exposed skin could freeze within minutes, and steel itself contracted and stiffened, making every bolt harder to turn. The straits never fully froze over. Instead, broken ice sheets moved unpredictably through the channel whenever wind and current shifted, striking barges without warning. Men who fell into that water in winter had a survival window measured in minutes. The shock of near-freezing water overrides voluntary breathing control, and drowning typically came before hypothermia even had a chance to set in. The 5 deaths on the project happened across its full span: falls, and at least one worker struck by equipment. Their names appear in accident logs. They don't appear on the bridge. Cable spinning began in spring 1956. After temporary wire mesh catwalks were stretched the full length of the bridge, following the same catenary curve the finished cables would take, dropping from the anchorages, down to the tower tops, down again through a long, shallow arc at midspan, back up and down to the far anchorage. Walking that catwalk end to end meant covering roughly 5 miles of flexing wire mesh at heights ranging from 200 to 552 feet, in wind that moved noticeably stronger the higher you climbed. A simple wheel carried wire back and forth across the span, one strand at a time, and each of the 2 main cables required 12,580 individual wires, meaning 12,580 full crossings of open air above the straits between April and October of 1956 alone. By October, the finished cables measured 17.5 inches in diameter, ready to carry everything that would eventually hang from them. Deck sections, fabricated on the mainland and lifted into place by floating cranes, extended outward from both towers toward the center, and when the 2 halves finally met at midspan, the alignment had to fall within exact tolerances Steinman's calculations demanded. It did. The mathematics had been right, and the construction had followed the mathematics exactly. The Mackinac Bridge opened to traffic on November 1st, 1957, 3.5 years after groundbreaking. The governor led a ceremonial convoy across. Bands played. Newspapers covered it nationally. What none of the photographs showed was the workforce itself. By the time of that opening, the ironworkers, divers, and laborers who'd actually built it were already scattered across the country on whatever job had come next. That's simply how construction works. The crew follows the work, And when the work ends, they leave without ceremony, while the structure they built stays behind under someone else's name. The revenue bonds that financed construction were fully retired by 1986, paid off entirely from tolls, proof the original financial gamble had worked. The bridge remains a toll facility today, under continuous maintenance, painting crews working year-round, cables inspected on a rolling schedule, deck sections checked for fatigue, tower shafts checked for corrosion. It's 68 years old as of this telling, and every bit of that open steel grid on the outer lanes is still doing exactly the job Steinman designed it for in 1953, letting wind pass through instead of building the pressure that tore apart a different Bridge 15. Years before this one existed, the men who built it are mostly gone from the record in every way that matters. The Kanawaka Mohawk ironworkers who erected its towers and deck came from a community that had already been building steel in high places for nearly 70 years by 1954. Structures across North America that carry the names of their architects and engineers, never the names of the men who actually put the steel together in open air. They lived in boarding houses in small Michigan towns for the length of the job, then went home to Kanawaki when it ended. The divers who spent months in compressed air 200 feet under the straits came and went the same way. The bridge is now one of the most photographed structures in Michigan, printed on postcards and even the state's commemorative quarter. None of those images carry a single name of the people who built it. If you cross the Mackinac Bridge today and stop at midspan, which isn't officially permitted, but people do it anyway, and look down through that open steel grid, you're looking 200 feet through air and then straight into water that's been running between these lakes for 10,000 years. Somewhere beneath that surface sits a concrete plugged caisson, sunk by men in canvas suits and copper helmets working in total darkness under 90 pounds of air pressure, exactly as deep as the engineers specified. It's still holding. The bridge is still there,